So we've talked about numbers in other bases. That's been fun. So what we're going to do now is we are going to do arithmetic in these other bases, because why not? So we're going to have a great time doing that today. So this is far over here. My first example looks like this. We are going to take 34 base something 5, and we're going to add that to 23 base 5. So I'm going to give you a moment to write that down, and then I'm going to tell you our in general process for how we're going to do these things. Now, as we've said before, if you were born base 5 and that was the number system you were immersed in, you wouldn't think about it like we're going to think about it. But we are learning something new, and so we are going to incorporate a little bit about how we think about numbers in with this. And so what I mean by that is we're going to forget for just a quick moment, for just a blink, we're going to forget that this is base 5. And 4 plus 3 is what? 7. Now, if you were a base 5 person, you would not say 7. Okay, you would say something different, just like when we add 9 and 1, right, it becomes 10, but we automatically know we carry the 1. Well, if you were base 5, that's exactly what you would do. You wouldn't even blink about it. Okay, but what I'm going to do is say, okay, 4 plus 3 is 7. So here's my question to you. And this is the question I'm going to ask over and over and over today. I'll write this down as well in just a moment. 4 plus 3 is 7. How many full groups of 5 is that? 7 is what? 1 full group of 5, so I'm going to carry a 1, and then how many left over? 2. Okay, so I'm going to write that over here. Okay, in base 5, if I have 7 of something, that is 1 full group of 5, 1 times 5, plus 2 left over. So because we had 1 full group of 5, I carried the 1, just like we would carry the 1 every time we have a full group of 10. Now, I know that's awkward, and that's going to be something we have to get used to. And that's why I have a bunch of examples on the sheet that I gave you. Okay, so if we don't get all the way through the sheet today, that's okay. Like I said, the last section of this unit is super short, so I want you to feel confident in this. I don't want to rush. Okay, we're going to do the same thing now with the next column. So I've got 1 plus 3 is 4, 4 plus 2 is 6. Again, 6 is not a base 5 number, but it's how we think about it. So 6 is, how many full groups of 5 is 6? It's 1 full group of 5, and how many are left over? 1. So I don't have another column to bring it over. So 6 is 1 full group of 5 and 1 left over. And there's my answer. 3, 4 base 5 plus 2, 3 base 5 is 1, 1, 2 base 5. All right, your turn. Execute exercise 1, please. Okay, so let's give this a try. It's a very similar problem, just this time instead of base 5, it's base 7. So this time as we're adding, we're going to add, we're going to continue to do our arithmetic base 10 because that's how we learned it. We'd have to do a lot of practice to begin thinking in terms of other bases. So we're going to do our arithmetic base 10, then we're going to ask ourselves the same question. We're going to rewrite that number in base 7. So here we go. 3 plus 6 is 9. Right, so we would write it as 9, but that's not a base 7 number. So 9 is, how many full groups of 7 is that? It's 1 full group of 7, and then how many left over? 2. 1 full group of 7, and 2 left over. So what am I going to do? I'm going to take the one full group of 7 and I'm going to move it up there. Because remember, in our base 7 system, each place is 7 times the previous one. And then I'm going to leave the remainder 2 right there. Doing okay? Any questions? I mean, this would be a great place for questions because this is difficult stuff. All right, same thing. 1 and 5 is 6. Plus 3 is 9 again, so I don't even need to write anything new. We just saw that 9 is one full group of 7 and then 2 left over. And that's all base 7. We'll put a little subscript so we know. So 5, 3 base 7 plus 3, 6 base 7 is 1, 2, 2 base 7. I'm going to do another example. Example 2 right below. So again, don't be shy. Ask your questions. I'm having a great time. I want you to have a great time. The next one is a base 3 problem. I just tried to vary the bases so that we just get used to doing this and not just get used to doing it with one base. So example 2, we have 2, 1, 2, 2. This is base 3 plus 1, 2, 2, 0 base 3. And we're going to add these two numbers right here. So again, base 3 means that every time I do this, I'm looking for full groups of 3. So my first column, 2 plus 0, 2. Don't need to divide anything up there. It's not a full group of 3. The next column, 2 plus 2 is 4, but 4 is not a base 3 number, so I got to come over here. 4 is how many full groups of 3? 1, and then 1 left over. So I'm going to carry the 1. That's the one full group of 3. And then this is the 1 left over. And then 1 and 1 is 2, plus 2 is 4. So again, that's one full group of 3 and 1 left over. And then 1 plus 2 is 3, plus 1 is 4. This is a pretty repetitive problem. So 4 again is one full group of 3 and 1 left over. So that's base 3. So 2, 1, 2, 2 base 3 plus 1, 2, 2, 0 base 3 is 1, 1, 1, 1, 2 base 3. So lots of 1s and 2s. Question? Am I going too fast through this? Don't let me go too fast. I get excited. I love doing math problems. Okay, but you might not share that same sentiment. I understand. So do the next one then. Exercise 2. It's another base 5 problem. I'm going to get started. If my answer differs from yours and you don't understand why, then just let me know. So 4 plus 1 is 5, and we're in base 5. So over here, 5 is one full group of 5 and 0 left over. No remainder. So it's one full group of 5 and 0 left over. There's my first column. Then the next one, 1 plus 1 plus 1 is 3. That's not a full group of 5, so I'm just going to write my 3 right there. The next column, 2 plus 0 is 2, so that's not a full group of 5, so I'll put a 2 right there. And then lastly, 3 plus 2 is 5. So again, 5 is one full group of 5 and 0 left over. So one full group of 5, 0 left over. And that is my answer in base 5. I got one more for us. All of the examples we've done so far have been bases that have been less than 10. So the last example, and it's no different procedurally, you're going to do that problem of a base that is bigger than 10. So this time, each column I go through, I'm looking for full groups of 12 because that is what my base is. I've got base 12 here. So before I get going though, remind me in base 12, what does the letter A mean? It's 10. What does the letter B mean? Great, excellent. So 2 plus B, that's 2 plus 11. For us, that's 13. That's how we would think about that. So I'm just going to come over here in my base 12 scrap work. So 13 is one full group of 12 and then one left over. So I've got one full group of 12, I carry the one, and then one left over. Again, are you tracking with me? If I do anything confounding, let me know. We have plenty of time. We're almost done with addition. The next column, 1 and 3 is 4, plus 6, that's 10. But again, if I'm base 12, how am I going to write 10? That's an A right there, 10. Don't carry the 1, I know that's our impulse. 1 and then put a 0 there, that's base 10 arithmetic. We're in 12. The next one is A is 10 and 7 is 17. So 17 is one full group of 12. And how many are left over this time? Okay, 5. So again, once again, my full group of 12, I carry the 1, and then I leave the 5 remainder right there. And then 1 and 9 is 10, plus 1 is 11. Well, 11 is not a full group of 12, so what do I write right here? A B. So B5A1. There you are. Those are my examples for addition. I think I've covered all the bases that I know to cover. But if you have a question, if something's not quite as obvious to you as I'm hoping it is, please let me know before I erase and we move on to subtraction. Okay, well, I don't want you to be bored because I'm just standing here. So before we do subtraction of other bases, let's just go back to elementary school. Okay, I don't know if that's a positive or a negative memory for you. And let's remember how to subtract. So let's say this is your quiz 401 minus 265. Okay, we're going to do this subtraction. Actually, let's not do 401. We'll do that. We'll do that one a little later. Let's do 481 minus 265. We'll do the 0 in a little while. When I go to subtract, it's the same thing as addition. You just go column by column, but I encounter a roadblock right away, 1 minus 5. I don't have enough up here to take 5 away. So when you were in elementary school, what did your lovely teacher tell you to do at this point? We're going to cross out this number because does anyone remember the name of the process? What are we doing with this column? We're borrowing, right? We're going to go to our neighbor. We're going to borrow some sugar. Okay, so we come over here. The 8 becomes 7. So here's what I'm doing, just to remind you of what we're actually doing when we do this. I've gone to the next column, which is 10 times more, and I've borrowed one. So I've borrowed a group of 10, right? So I've gone over here. I'm borrowing a full group of 10. And then I don't know how you notate it. Different teachers teach their kids to notate it differently. I don't know. But I'm going to take that group of 10, and I'm going to come back here. Now, instead of 1, how many do I have in this column? I have 11. I'm going to write 11 right up there. So the key, and if you can remember this thing, it's the same thing when we go to do this other basis. I had to borrow. I borrowed, in base 10, I borrowed a full group of 10. And I went over here. Now it's 11. So now 11 minus 5 becomes 6. 7 minus 6 is 1, 4 minus 2 is 2, and 216. There's my answer to that problem. I'm going to do the same thing now, but this time I'm going to do it, well, you know what? Let me do my original example too, just so I cover all my bases. So now instead of 481, my original one was 401. So let's do this just to make sure I've done all the examples of base 10 that I need to. So now I've got to borrow again, same thing, but now when this one looks to its neighbor, what does the neighbor say? I don't have anything for you, right? Got to borrow, you got to go over. So we go over to the 4. Okay, now we borrow from the 4. The 4 becomes a 3. I borrowed a full group of 10 from right here, right? So I borrow a full group of 10. What does the 0 now become? A 10. Now, some teachers teach you to skip this step, and I totally understand, but I'm just trying to show you exactly what you've always done and you've taken for granted. So we borrowed from the 4 becomes a 3. That's a full group of 10. The 0 becomes a 10. But that wasn't really what I cared about to begin with. I wanted to borrow to do this. So now what does the 10 become? A 9, because I'm borrowing. I'm borrowing a full group of 10, so the 1 becomes 11. Now, some teachers teach you just to skip the 10 part and you go right to 9. I understand. So, okay, it's nice to have shortcuts. Okay, but that's what, at some point, somebody taught you that's what you're doing when you have a 0 there. So 11 minus 5 is 6, 9 minus 6 is 3, 3 minus 2 is 1. This time I get 136. So all that to say, this is my first example. Okay, so I've got 3032, this is base 4, and minus 100, minus 10, oh, it's base 5, I'm sorry. I was looking at a different problem. 3032 base 5, 1004 base 5. I'll give you a minute because I know I goofed that up. You can write it down. So in my example, I have both types of borrowing we're going to do. We're going to be able to borrow right from the next column, but then we're also going to have to borrow across the 0. So that's why I want to do both those examples. Okay, here goes. So 2 minus 4, roadblock. So I'm going to go over to the 3. The 3 now becomes a 2. Now we're not base 10, we're base 5. So I've borrowed a full group of what now? Okay, borrow a full group of 5. That's what base 5 means. Now I'm going to allow us, okay, again, if you were a base 5 person, you would not write this down. This would have no meaning to you, but we're going to incorporate just so that we know where we are. So I borrowed a full group of 5. So when I come over here, the 2 now becomes a 7. Okay. Now again, there's no number 7 in base 5. This is our little notation, okay? Instead of writing 1, 2 here, which would be how a base 5 person would write what we call 7, okay? But that becomes too complicated for us. That's too much base 5 stuff. So we borrowed a full group of 5 from this column, becomes 7. 7 minus 4 is 3. 2 minus 0 is 2. 0 minus 0 is 0. 3 minus 1 is 2. And there's my answer, 2023 base 5. The key to remember is just the reverse of addition. When you borrow, you're borrowing a full group of whatever the base is. So here's your first example that I would like you to do. This is exercise 4. Exercise 4 says I would like you to do 402 minus 235. And this is base 6. All right, so this is a hard problem. So any issues you have, let me know. I've got a couple more examples, and if you still aren't sorting it out, I can make up another example. It's really quick and easy to do. So 2 minus 5, I got a roadblock, so I've got to borrow. I go to the 0 to borrow. There's nothing there, so I've got to go over to the 4. Okay, now the 4 becomes a 3. I'm hoping you're tracking with me so far. What have I borrowed a full group of? A full group of 6. So now the 0 here becomes a 6. Again, if you were a base 6 person, that would have no meaning, but that's my accommodation to we are base 10 people. Okay, so I borrowed a full group of 6 here. The 4 becomes a 3. That makes the 0 a 6, but now I am borrowing. So what am I going to make the 6 into? It becomes a 5. I have borrowed a full group of 6, and so now the 2 becomes a 8. Yes. Difficult stuff, I understand. That's why we're going to do several examples. Now you're ready. 8 minus 5 is 3. 5 minus 3 is 2. 3 minus 2 is 1. So you get 1, 2, 3 base 6. Next problem. Stop me if you have a question. If not, let's enjoy the ride. The next one is 3, 2, 1, 4 base 5. And we have 2, 4, 2, 1 base 5. So go ahead and subtract those two numbers, please. Because I can't do 2 minus 5, right? Oh, no. So my original thing was to borrow from here, but there was nothing to borrow. So it's okay. It's some stuff. So I mean, it's making me happy. So I'm going to come over here. I borrowed from here to restock the shelves here, and then I had to borrow from here to restock the shelves. Okay. That's what had to happen. Great question. If you don't see it, ask it. So I have 3, 2, 1, 4 base 5, 2, 4, 2, 1 base 5. So my first column works out to be nice for me. 4 minus 1 is 3. That's true in any base, so good. The next one, 1 minus 2, that's where I hit my roadblock. I don't have enough in the top to subtract 2 from, so I'm going to borrow. So I come over to the 2. The 2 becomes a 1. I've borrowed a full group of 5, so this column now becomes a what? 6. Great job. 6 minus 2 is now 4. Same thing happens now. I've borrowed, so I have a 1 here, and I got to subtract 4. That's not going to work out for me. So I come over here and borrow. This becomes a 2. I borrowed a full group of 5 again, so this is going to become a 6 once again. 6 minus 4 is 2. 2 minus 2 is 0. Base 5. Here's another one. Again, we've had bases less than 10. Here's a base bigger than 10. And before we move on, if you need another example, we'll do another example. So please let me know. Be honest with me. Hey, if you need another example, there's probably somebody else in the class that needs it too. This is both base 12. We said the last time we encountered base 12 that A meant 10, B meant 11. So my first column Actually works out to be pretty good. A meaning 10 minus 8 is 2. Now I have 7 minus 11. Can't do that. So I come over to the 9. What does the 9 become? 8. Thank you. I borrowed a full group of 12. So this column now becomes 19. Yes, we're going to write a 19 there. So 19 minus 11. 19 minus 11 is 8. And then 8 minus 4 is 4. So we get 482 base 12. That's adding, that's subtracting. Before I move on, do we need another example of any of these? Either something that with a base below 10 or a base above 10. Okay, well, we're going to be here till 1:15 regardless. You don't have to worry. Not asking questions because you just want me to stop. I can understand that. I've been in that class too. All right. We've added, we've subtracted. Now we are going to multiply. Well, here goes. I've got 1, 3 base 5. And I'm going to multiply that times 3 base 5. I'm going to give you a moment to write that down. And then we're going to talk it through. So again, we're in base 5 world. So at each time I do this, I have to convert everything to base 5. So again, we're going to start off. We're going to think in base 10. So 3 times 3 is 9. Yes, you've known that since elementary school. Great. But I'm not going to write a 9 here. So I'm going to come up here in base 5, just like we were doing with addition. 9 is how many full groups of 5? It's 1 full group of 5 and then 4 left over. So I'm going to put 4 right here. And then I'm going to carry the 1 full group of 5. And again, I'm sure you know how to do this, but just remind me, when I go now to do this again, what am I going to do with these two numbers right here? You multiply. And then what do I do with this number that I carried over? You add. Okay, that's the process that we've been using since elementary school. So 3 times 1 is 3, plus 1 is 4. 4 is not a full group of 5, so I'm just going to put a 4 right there. So we get 4 base 5. Do exercise 7, please. 2 4 base 7 times 5 base 7. Take this next bit slow, because for the first time, we're going to have a little bit of a different answer to this question. So 5 times 4 is 20 in our way of thinking, but we're not thinking like we are. We're thinking base 7. So 20 is, how many full groups of 7 is 20? Okay, 2 full groups of 7. So that's the first time we've answered the question that way. What's 2 times 4? 14. So how many are left over? 6. Okay, so when we multiplied 5 times 4, we got 20. 20 is 2 full groups of 7 plus 6. So I've got my 2 full groups of 7, and then I've got my remainder of 6. Everybody tracking with me? Even if you didn't get it the first time around, you see where we are? Same thing here. 5 times 2 is 10. 10 plus 2 is 12. The way we think about it would be 12, but I got to convert this to base 7. So 12 is 1 full group of 7 and 5 left over. So 1 full group of 7 and 5 left over. So we get 156 base 7. Difficult problem. If you didn't get it the first time around, that's okay. We're going to do a few more examples. So let me know. I'm going to do example 6 because I want to remind us all of something. So let's do this. Let's say I have 4, 3 base 7 times 2, 5 base 7. Just reminding ourselves what happens if the number in the bottom when we're multiplying has more than one digit. What do we have to do? What's the process? So do me this favor. Let's do this. I want to make sure forget the 2 for a minute. I'm going to give you 35 seconds. I want you to multiply the 5 times the 4, 3, just like we did over there, and get the first line of this. And then you can stop, or unless you want to make a hypothesis. Okay, so I'm not worried about the 2. I didn't ask you to do anything with the 2 yet. Okay, so 5 times 3 is 15. And so 15, how many full groups of 7 is 15? It's 2 full groups of 7, and then that would leave me 1 left over, because 2 times 7 is 14, plus 1 makes 15. So it's 2 full groups of 7, and then 1 left over. 5 times 4 is 20. 20 plus 2 is 22. How many full groups of 7 is 22? It's 3. So 3 times 7, that's 21. 3 full groups of 7 plus 1 left over. So I have 3 full groups of 7 plus 1 left over. Okay, you're right where I need you to be. Again, we're flashing back to elementary school or middle school. Now I'm multiplying the 2 times all of this. What am I going to do in my answer down here? What do I need to remember to do? Yeah, okay, so different teachers teach different things, and it's equivalent. If your teacher said, okay, now that we're in this column, because remember, we make our columns line up, you can put a 0 here to remind yourself that you're in the second column, right? My teacher just taught me to indent, but if you don't write anything, it's 0, okay? So it doesn't matter. So put the 0 there. That means I'm now in the second column. So now multiply the 2 and write your answer right here, and then we'll be just about to the finish line. So now 2 times 3 is 6. 6 is not a full group of 7, so I'm just going to write a 6 right here. So again, notice all of my numbers should line up. This is all my units. This is all my 7s. This is all my 7 squared. So continuing, 2 times 4 is 8. So 8 is 1 full group of 7 plus 1 left over. So 1, 1. Here's the key. Most commonly missed thing, okay? Normally on this test coming up, students are good at adding, they're good at subtracting, they're good at multiplying. But don't forget this detail. What do we do with these numbers now down at the bottom? You got to add them, right? But don't forget your base 7. Okay, sometimes we revert, like we get loose and we're like, okay, I've done all the fun stuff. So I'm just going to make a little note here for you. It's really the biggest mistake students make on multiplying is they do the multiplying base 7 just great, and then forget that we're still adding base 7. So don't forget that you have to add up base 7, or whatever the base is, in this case, base 7. So 1 plus 0 is 1, doesn't apply, but then sometimes 1 plus 6 is 7, and if we're not thinking about it, we just write the 7 and move on. But remember, in base 7, the number 7 is 1 full group of 7 and 0 left over. So 0 is left over, it's 1 full group of 7. 1 and 3 is 4, plus 1 is 5, and then 1, and we're in base 7. Well, with that said, the next example. 2, 3, 4 base 6 times 5, 2 base 6. Get started, check your work with my work. If we differ, ask a question. We're base 6, and keep that in mind. So first column, 4 times 2 is 8. 8 is 1 full group of 6 plus 2 left over. So 8 is 1 full group of 6, 2 left over. 2 times 3 is 6 plus 1 is 7. 7 is 1 full group of 6 plus 1. Now, you don't need to write this down. If you're getting better at just thinking that through, that is fine. Just writing this down in case you're not there yet. Totally get it. So 7 is 1 full group of 6 and 1 left over. So 1 full group of 6, 1 left over. 2 times 2 is 4 plus 1 is 5. That's not a full group of 6, so we'll put a 5 right there. So the first line should be 5, 1, 2. We're indenting. We're going to the 6's column. So I'm going to put a 0 here in the units. Just as an aside, I don't know if my next one has this or if there's one more. If there was a number here, what would we do in the next line? Yeah, you put 2 zeros. Okay, you always want to be lined up with where you are. Okay, so that's not this problem. I just wanted to mention it. Okay, so 5 times 4 is 20. 20 is how many full groups of 6? 3 groups of 6, that's 18, so I need 2 more. So it is 3 groups of 6 and 2 left over. 5 times 3 is 15, plus 3 is 18. And 18 is 3 full groups of 6 and 0 left over. So 3 full groups of 6 and 0 left over. And last but not least, 5 times 2 is 10, plus 3 is 13. 13 is 2 full groups of 6 and 1 left over. So 2 full groups of 6, 1 left over. And now we add up. We're adding in base 6, although I don't think it's going to matter on this one if you forgot that. So we've got 2, we've got 3, we've got 5, 1, and 2. And that's all base 6. I've got one more multiplication problem on the sheet. If you need another example, feel free to ask me for another example. If you don't, then we'll move on to the last operation, which is division. So exercise 9, base 2. Base 2 is a lot of fun. Lots of 1s and 0s. so I'm going to get started. Check your work with my work. Now, the nice thing about base 2 is everything's ones and zeros, and those are the two best numbers to multiply by. Okay, so 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. Fantastic. Then I'm going to indent, so I'm going to put a 0 here because I'm indenting to the second column. So I go through the same thing again. 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. Fantastic. And I'm going to do the whole thing again. I'm indenting to the third column, so I'm going to put 2 zeros here, and then I'm going to do the same thing. 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, and 1 times 1 is 1. Woo! Lots of ones and zeros. Am I even still on the screen? Oh, just barely. Good job, Frickster. All right. Here's where you just got to be careful. That's not too big of a deal, 1 and zeros. But now remember, we're adding base 2. That's the key. We're adding base 2 here. So when I come down here, this is 0, that's not too bad. This is 1, that's not too bad. This is 1 and 1 is 2. Okay, 2 is 1 full group of 2 and 0 left over. So it's 1 full group of 2 and 0 left over. Everything in your answer should be zeros and ones when you're base 2. It's kind of the fun of it. So then 1 plus 1 plus 1, that's 3. 3 is 1 full group of 2 and 1 left over. So it's 1 full group of 2 and 1 left over. 1 plus 1 plus 1 is 3. Again, that's 1 full group of 2 and 1 left over. 1 and 1 is 2. 2 is 1 full group of 2 and 0 left over. And then 1 and 1 is 2. That's 1 full group of 2 and 0 left over. Woo! And there we go. 1, 0, 0, 1, 1, 0, 1, 0. And that's the message we send up in space. All right. This is difficult stuff. Okay, so I know we're flying through it. If you have questions, more examples. The last one's division. Division, we're going to end on the high note. I've taught this class a bunch of times, and I've taught division a couple of different ways. So I'm going to teach you the easiest way, and I'm sure you're thankful. Like if I said I'm going to teach you the hardest way to do the division, that would just be rude, right? That'd be mean. So we're going to do 140 or 143 base 5. We're going to divide it by 2 base 5. Now in this class, we're only going to divide by single-digit numbers. Okay, dividing by 2 or 3-digit numbers becomes way more complicated. It's not worth the learning that you would do. So I'm going to take 143 base 5, and I'm going to divide it by 2 base 5. Now, before we do that, you don't have to write this down again. We're just going back to elementary school. If I had something like 4 and I want to divide it into 134, remind me the process. When I look at this, I say, okay, 4. 4 goes in. What do I look to 4 to divide into? And the 4, does it divide into the 1? No. So now I look at the 4 to divide into what? So 1, 3, right? The 13. And now you revert back your multiplication table. This is why your elementary school math teacher made you memorize the multiplication table. How many times is 4 going to 13? 3, because 3 times 4 is 12, right? So 3 times 4 is 12. That's your multiplication table. And then we subtract, get a 1, we bring down the 4, and we go through the whole process again, and you do it until you run out of numbers. So 4 goes into 14 again 3 times. 3 times 4 is 12, and I'm left with 2. And then the first way you learned to divide before you had the fun of learning about fractions or decimals is you wrote, okay, there's a remainder of 2. Okay, well, same thing. But the only problem for us is we don't know our multiplication table is base 5. So the way that we are going to engage this process so that we can do this quick like this, because we know our multiplication table times 4. You know, 2 times 4 is 8, 2 times 4 is 12, 4 times 4 is 16, etc. So what we're going to do first, step 1 in this process, is we are going to write we're going to write our multiplication table for 2 base 5. And what that means is we're going to go through and we're going to multiply 2 by each of the other digits I have base 5. And so, all right, so I'm going to leave off all the little 5s just so that we don't go crazy looking at it. But this is base 5. Well, no, I shouldn't leave off. But let me be a good instructor. I'm going to put the 5s on there. So 2 base 5 times 0. Well, I love multiplying by 0. What's 2 times 0? 0. Okay. 2 base 5 times 1. Well, 2 times 1 is 2. That's 2 base 5. 2 base 5 times 2. 2 times 2 is 4. 4 is not a full group of 5, so I'm just going to write 4. And I'm doing this for each of the digits base 5. And if you remember when we first started talking about other bases back in section 2, I told you in any system of numeration, when you have your base, you have, if I'm base 5, I need 5 digits. If I'm base 6, I need 6 digits. If I'm base 10, I need 10 digits. So my 5 digits are 0, 1, 2, 3, and 4. So I got 2 base 5 times 3. Now here's where it gets fun. 2 times 3 is 6. 6 is 1 full group of 5 and 1 left over. And then last but not least, 2 base 5 times 4. 2 times 4 is 8. So 8 is 1 full group of 5 and 3 left over. And that's your multiplication table for 2. Why did I pick that? Well, I picked it because whatever you're dividing by, do the multiplication table for it. And now we will use that information right there to do the division problem. All right. You told me just when we did this a minute ago with base 10, my first thing is to look, does 2 go into 1? No. 2 doesn't go into 1 base 10. 2 doesn't go into 1 base 5. The same thing. Does 2 go into 1 4? Well, it's going to. What's the closest thing I have to 1 4 over there? 1 3, right? So I'm going to multiply by a 4 up here. Now we've already done the multiplication table. We've already done the hard work here of the multiplying. So 2, and you can do it again if you want. 4 times 2 is 8. 8 is 1 full group of 5 and 3 remaining. So now I do my subtraction. 4 minus 3 is 1. 1 minus 1 is 0. I don't need it. Now I'm going to bring about the 3. I'm going to do the same thing, ask the same question. What's the closest I can get to 1 3? Well, I can hit it dead on, right? I can multiply by another 4. 4 times 2 is 8, and 8 is 1 full group of 5 and 3 left over. So I end up with a remainder 0. So I'm not going to write R0 up there. This is the answer. The answer, how many times does 2 base 5 go into 1 4 3 base 5? The answer is 4 4 base 5. So I should have put this exercise on there. We've got plenty of time. Division's the hardest operation. So we're going to take advantage of the fact that we've already thought through the multiplication tables 2s. We're going to take advantage of that work before we move on. So I'm going to just give you another. This is not, flip over to the back of your page where it's blank. This is not an exercise on the thing, but I just want to make sure that we're going to go through with the multiplication table we already got. So take 2 base 5, and this time I want you to divide it into, let's say 1 3 4 1 base 5. All right, let's try this out. The multiplication table's right there. So 2 goes into 1, 3. Well, we can hit that dead on by putting a 4 right here. 4 times 2 is 8. 8 is one full group of 5 and 3 left over. This time I have 0. So I bring down the 4. 2 goes into 4. Well, I can hit that dead on too. So 2 times 2 turns out to be 4. Again, I have 0. So I bring down the 1. Here's something not to forget when you're dividing. Does 2 go into 1? No, but we have to account for each place value, right? So what do I have to put right here to say that 2 does not go into 1? I put a 0 right there. So I got 4, 2, 0, and then my remainder is 1. And it's 4, 2, 0 base 5. I'm not too fussy about this. My math lab might be a little more fussy. Your remainder, the book and my math lab will put a 5 right there. I'm not fussy about the base on the remainder because it's kind of assumed, but make sure you're putting your base on the quotient, what you get as your result. All right, second to last problem for the day, exercise 10. So before we do the division though, what I would like you to do is I'd like you to write out your multiplication table for 3 and base 5, just like we did here for 2. I want you to do the same thing for 3, and then go ahead and pause, and we'll all make sure we're at the same place. All right, so let's make sure we all have the right multiplication table for 3 base 5. So 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 6 is one full group of 5 and 1 left over. 3 times 3 is 9. 9 is one full group of 5 and 4 left over. And then 3 times 4 is 12. 12 is two full groups of 5 and 2 left over, because 2 times 5 is 10 plus 2 left over. So there's my multiplication table base 5. If somebody is not understanding where these numbers coming from, let me know. I can come over and check out what you're doing. In the meantime, if you're good with that, go ahead and do 3 base 5 divided into 1, 3, 4 base 5. So the first one, 3 again does not go into 1. So 3 goes into 13 though, or 3 goes into 1, 3. The closest I can get is 1, 1. 1, 4 is bigger. So 1, 1, so I'm going to multiply by 2. 3 times 2 is 6. 6 is 1 full group of 5 and 1 left over. Now I do my subtraction, I get 2. I bring down the 4. And now how close can I get to 2, 4? Well, that is going to be 2, 2. So I multiply by a 4 up here. 4 times 3 is 12. 12 is 2 full groups of 5 and 2 left over. And again, I subtract and I'm left with 2. So my answer is 2, 4, base 5 with a remainder of 2. A 0 where? There's no other numbers here. So I didn't, on the other one that we did, we had brought down a number and then I wouldn't go in. So 1, 4, 1, 2, 4, 1, base 5. So yeah, so get 2 base 5. So then what was the first thing right here? Somebody remind me. It was 3? 3 times 2 is 6. So that's 1 full group. And then, no, this was a 3, wasn't it?
Yeah.
Okay. So 4 times 2 is 8. 8 is 1 full group of 5, 3 left over. So I've accounted for this place right here. Then I brought down the 4. And so now 2 can go into 4. So that goes 2 times. 2 times 2 is 4. Now here's the difference. I bring down the 1. Right? 2 does not go into 1. But that's the number I brought down. So I have to put something over that number right there. So that's why I have to put a 0 there. Over here, we brought down the 4, and I found a number to go into this. So I've accounted for that place. So what's left here is just the remainder. You're right, 3 does not go into 2. You should never be able to divide into your remainder. Otherwise, you have something you have to fix up there. Okay, so there's no other number up here that I dropped down that I couldn't divide into. That's the difference between the two situations. Okay, so I don't need a 0 at the end of this because I have no more number. The 1, the 3, the 4, I've accounted for every place with a number in my division. So be careful. This is a great time to mention notation. When you're dividing the 3 into the 1, 3, don't put the 2 over the 1. Okay, because you didn't divide into the 1. You divide it into the 1 and the 3. So the 2 goes over the 3. You always put your number over what place you're dealing with. Is that a little better? Sort of? Yeah, so that's the remainder. And so then after I account for this, because 0 times 2 is 0, that's why that becomes the remainder at the very end. I've got one more problem for us for division. We've got just enough time to do it. We're going to do 3, 4, 1, 0 base 6 divided by 5 base 6. So what you're going to do first for me, and then we'll pause and we'll regroup, is you're going to do the multiplication table for 5 base 6. Remember, for base 6, you need to have 6 numerals. So you're going to start with 5 times 0, and then you're going to go up to, and you're going to do 6 numbers. So for my base 6s, my 5 base 6, 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10, but I'm in base 6, so 10 is 1 full group of 6 and 4 left over. 5 times 3 is 15. 15 is 2 full groups of 6 and 3 left over. 5 times 4 is 20. 20 is 3 full groups of 6 and 2 left over. And then 5 times 5 is 25. 25 is 4 full groups of 6. 4 times 6 is 24, and 1 left over. So there's your multiplication table, base 6 for 5 base 6. Oh, I didn't give you time. Yeah. I'm base 6 this time. If this was base 5, then yeah, the numerals for base 5 are 0, 1, 2, 3, 4. Then you have full groups of 5. When you're base 6, I need 6 numerals. So it goes 0 through 5. 1, 2, 3, 4, 5, there's 6 numerals. So if we were base 7, we would then go times 6. Okay, you need the same number of numerals as the base that you're dealing with. Okay, great question. So go ahead and do that division, and then we will be just about done for the day. One more time. Yep. All right, just for time's sake, I'm going to finish this up. So if you're working, keep working. We'll check answers. So 5 does not go into 3. 5 goes into 3, 4. The closest I can get to 3, 4 is right here, 3, 2. So I multiply by 4. 4 times 5 is 20, and we determined that 20 is 3 full groups of 6 and 2 left over. I bring down the 4 minus 2 is 2. Now I'll bring down the 1. 5 goes into 2, 1. The closest I can get to that is 5 times 2 here is 1, 4. So 5 times 2 is 1, 4. Now we have to be careful. Same thing as when we add. We have to remember we're adding in different bases. We're subtracting base 6 here. So I say that because I have to borrow. So I go over here, I got to borrow from the 2. 2 becomes a 1. But what have I borrowed a full group of? Full group of 6. So this 1 now becomes a 7. And 7 minus 4 becomes 3. Okay, so just make sure you keep that in mind. This whole problem is being done in base 6, even though we do some of our thinking in base 10. Then I bring down the 0, and I go through this all one more time. 5 goes into 3, 0. You notice this line right here, 5 times 3 is 2, 3. So 3 times 5 is 15. That is 2 full groups of 6 and then 3 left over. Again, I'm subtracting in base 6. So I borrowed a full group of 6, and 6 minus 3 is 3. So the answer to this is 4, 2, 3 base 6 with a remainder of 3 base 6. It was great to see you. I only get to see you one time this week. Hope you're as sad about it as I am. I will see you on Monday. We will do our last